Question 20a. Rank the currents in the circuit from greatest to the least, with number 1 being the greatest. If two resistors have the same current, give them the same ranking. Explain your reasoning. So here in the circuit we have three resistors, RA, RB and RC. And all three of them have the same value of resistance R. The current through the circuit is shown in the figure. And we need to rank the value of current for each of them. So we will start with applying Kirchhoff junction rule at junction A here. We know from Kirchhoff junction rule, sum of all currents which are entering the junction must be equal to sum of current which are leaving the junction. So at junction A, current IB and IC are entering it. So IB plus IC will be equal to current IA is leaving the junction. So that is equal to IA. So we get that IA is sum of IB plus IC. Now if IA is sum of IB and IC, then obviously IA must be greater than IB and it must be greater than IC. So we can rank IA to be the greatest current over here. So the ranking of IA we will give as 1. Then we have to rank IB and IC. Now if you look at current IA here, it splits at the junction here, we will call this junction B, and divides into IB and IC. The magnitude of current IB and IC will depend on the resistors RB and RC. Greater the resistance, smaller will be the current flowing through it, and smaller the resistance, greater will be the current flowing through it. Here both RB and RC have equal value. So if RB is equal to RC, current in them will be divided equally. So we get IB to be equal to IC. So both IB and IC are equal. So we will give them equal ranking, which is 2. So this is how you can compare the magnitude of current using Kirchhoff junction rule, given the values of resistance in the circuit. Question 20p. Rank the voltages across the three resistors in the circuit from greatest to least, with number 1 being the greatest. If the two resistors have the same voltage, give them the same ranking. Explain your reasoning. So here in the circuit, we have three resistors RA, RB and RC, and each of them have the same resistance R. The direction of current IA, IB and IC are as given. And we need to compare the potential differences across RA, RB and RC. Now we can find potential difference across a resistor using Ohm's law, which says that potential difference V is the product of current times the resistance. And once we know the values of current and resistance across a resistor, we can find its potential difference. Here resistor RB and RC are connected in parallel. And we know for any parallel circuit, potential drop across each parallel branch is equal. So potential drop across RB, which we will write as VB, must be equal to potential drop across RC, which we will write as VC. So voltage of VB and VC are equal, but we need to still find how they compare with potential drop of A. So let us first find equivalent resistance of these two. First, we will combine RB and RC. So when you combine them, both RB and RC have same resistance R. So I get their equivalent resistance RBC to be equal to 1 over R plus 1 over R raised to negative 1. So RBC becomes equal to R by 2. Then when you reconstruct the circuit, you get the battery here, resistor RA, and then the combination of B and C, which is RBC. RA is equal to R, RBC is R by 2. And since this is a series circuit, same current flows through RA and RBC as the total current I of the circuit. Now here the current through the circuit is the same. So the resistor which has the greater resistance will have greater voltage because voltage is directly proportional to the current and resistance. If I value remains constant, whichever resistor has greater value of R will have greater potential difference. So here RA is greater than RBC. That means the potential difference across RA must be greater than potential difference across RBC. So we can write potential difference across VA is greater than VBC, and voltage VBC is nothing but voltage across resistor RB and RC since they are connected in parallel. So this gives you VA greater than VB, whereas VB and VC are equal. So we can rank them as VA is 1, VB 2, and VC 2.